recording. So today is chapters 9 and 10, and holy balls, these were long. Uh, so it's gonna talk about very important stuff called S expressions and a way to do meta programming, which is very interesting. I actually want to hear what Marinho wants, Marinho's opinions on chapter 10. It's gonna be very interesting. Okay, so this is the part that he said in the beginning that we're gonna talk about pointers later. So this is that part. So blah blah blah. This is gonna be very wasteful in terms of memory if you're gonna do copy by value. And in fact, there are some situations like dynamic arrays that you actually cannot do copy by value because they don't have a fixed size. So on and so forth. I think everybody here knows about this. And then he explains that when you do know the size, things can live on the stack, and when you don't know, it's gonna go in the heap. And the stack is actually also where you do the context switching between function calls.
I have
Uh,
to confess the heap is still kind of magic for me.
oh,
Because
but this is like where you do mallocs and hallocs and frees,
yeah,
basically.
I understand, but it's kind of magic because this area is managed by the operational system, right?
Mm-hmm. Yeah.
Kinda, not really.
Yeah,
Technically, it's
it's
managed by the C runtime by malloc and free, but you can actually choose a different
No.
implementation
You
than
got it wrong,
the one
Marinho.
that.
You got it wrong. The so you actually you are both right. So let's see if I got this right, right? So it is the C runtime, that's true, but that's not actually how it talks to the hardware. There is actually an upper level, which is the memory manager, which I believe can also be done in hardware. I remember talking about that in Sysmiki. Anyway, that doesn't matter. So these two things they communicate with each other. So the operating system it has like an upper supervisor of the memory, and the C
Mhm.
runtime talks with that as far as I'm aware. And I also remember
Um,
that the idea of continuous memory in the past that was not actually a thing. Like that was kind of an illusion because the memory manager would do the math for you of the what the heck is happening in the memory itself, and then you can think it's continuous, but it maybe not be in the past. I remember a professor saying that. And that is crazy, right? Imagine writing a software that is actually handling the memory and give you the impression that it is continuous. That's crazy.
Oh yeah, the hardware does some nasty stuff. to the memory.
Imagine, man, imagine. Anyway, I
yeah,
think I think you got my point, my name, right?
yeah, I did,
Okay,
and
so
you are correct. You are
okay,
correct.
so then the heap
Let
stuff, this
of
is what we don't like to
uh,
do actually. This is where garbage collection, reference counting, this is where all of that goes in. Go on, Mari.
I mean, there is one exception actually where I am correct with no caveats, and that is if there is no operating system. But then you're kind of
But then you're
screwed either way.
trolling. But then you're trolling, right? Anyway, okay. Okay, so this is basically it's so annoying to have you when you need to do this sort of stuff. It's very annoying.
What
Uh,
kind
you have to do the memory management by yourself and do the freeze and stuff like that.
mm,
You need to remember to do those and stuff like that. And then you
Yeah,
pass val grind and you're leaking like crazy. Yeah.
mm.
yeah, about that. Um, there is actually one situation where it's actually a legitimate strategy to just leak memory and not care about it.
Which is?
And that is if if you're going to run a relatively short process and it's gonna end, and then the operating system is gonna clean that up, why would you bother reclaiming memory if the
No. But
OS is
then
already
but
gonna
then
do it
you're
for
running a
you?
script, right? It's something very fast. It's not even batch. It's just like tune enter and then runs and then it dies. Memory leaking is a problem when the thing needs to continuously run, right?
Yeah, yes. In that case, it is a problem. Yes.
Yeah.
That's
Anyway.
actually an area where, fun fact, that's actually an area where your language actually matters. Like C, you have to do malloc and free. Like the language itself doesn't really help you with that.
Oh yeah.
In Zig, you also have to do malloc and free if you're doing heap allocation, but it steals the idea of the defer keyword from Go. So you can actually have malloc and free right next to each other
Ah, okay,
syntactically.
okay. So do you know what defer does, Iju?
What?
Defer.
What is differ?
Defer is is a keyword that I think got popular because of Go,
Mm.
which
Yes.
is you allocate some memory and then immediately after that you can put a defer. And what the defer is gonna do is it's gonna at the end of the scope of this function, it's gonna free everything that was allocated.
Sounds
Yeah.
nice.
Yeah,
Great.
it's
Actually,
basically a positional thing, right? So they know that you're gonna forget, so they allow you to put anywhere. So and then the defer is just gonna do scoping. Okay, go money.
yeah, so Zig took that idea because it's actually pretty easy to implement even without a runtime. And so
Yeah.
Zig just has defer, and that actually makes it easier to use C libraries in Zig than in C because
Yeah, that
you
makes
can just
sense.
do
You can just
you can just
defer.
do allocate this, then defer free, and you're
Yeah,
done. No need
yeah,
to
yeah.
no need to
Crazy.
mess around. Yeah.
Yeah,
This
that's
is,
really cool.
sounds like Rusty. Ru-
Sounds a little bit like it,
It,
right?
it sounds like Rust just got nuts with this kind of behavior and dropped a keyword anyhow.
Yeah, I
Sounds like.
agree. I agree.
Yeah.
Okay, next up is we're gonna So it's basically talking about that because we're gonna enhance the expression. Actually, I think it's a little bit misleading. Before we didn't have a complete notion what the heck is in the expression. But now we're gonna have because now we're gonna make add to our grammar something called an XPR, which will hold a bunch of new stuff. Which will hold a bunch of new stuff. So we're gonna
Yeah,
add to
and
our enum of possible things in our language.
These are the
and
types,
the
right? More or
yeah,
less.
that's the type tag actually. Yeah.
Yes. Yeah.
Yeah.
Then
Then
we're gonna
this is the
enhance the struct of the lval. Uh,
enhanced asterisk. It actually gets more wasteful as it grows.
no. But
That's kind of
enhance in terms of
sad.
functionality. The hardware is cheap. Just buy more memory. Who cares? I already told you that.
But no,
S-
man, but I wanna run this in I don't know, in a PS1 emulator or something.
yeah, you need to stop. You need to stop dreaming like Magetta, man. Like Magetta has a 32-bit Mac Cube. Edu, you know what is that? A Mac Cube?
I know what it is.
He has one of these. Magetta.
Oh man, it's so beautiful, this shit. It's an acrylic thing. Very beautiful.
Yeah.
Oh, love Mac.
Anyway, hi Mac. Hope you're doing all right. So we actually see this counter. This is actually pretty common in dynamic arrays implementation in C, assuming
Mhm.
that everything that Zozin does is right, because he does this all the time. Uh,
Um, Zig actually takes this idea and kind of bakes it into the language. There's this concept of a slice, which I think the nomenclature actually comes from Go as well. A slice is basically a fat pointer. So like you have a pointer, you have the length, and they travel together like a
mhm,
struct
mhm,
basically.
mhm. I think it's a
Yeah,
little bit obvious why we want to have this static, like as a value, because it's very wasteful to have to compute this every time. So you just keep it as it is.
or search
And
for the
actually,
for the end of something, right?
Yes, oh, that is also true. You're gonna have to search for the
and
end of it.
and depending on how you implement it, you may not actually be able to search for the end. So you need to know this
Yeah,
information
yeah, yeah,
anyways.
yeah.
Mm-hmm.
There's also an explanation why the heck we need a pointer to a pointer. Uh,
It's because it's an array of pointers basically.
it's an array of pointers, yes. And this was funny. Like being evaluated. How many stars as a programmer that you are is based on how many pointer indirections you add to your code.
Do you know
Crazy.
Peixoto? He mentioned to me, I don't remember when, but he mentioned working with a real code base which the guys were using 7 stars things.
What?
7 stars things.
Imagine 7 stars, man. Imagine.
It was some kind of video compression, and it was the official standard.
Is this Dragon Ball now?
What?
Is this Dragon Ball now? Yeah, yeah. But yeah, but it's people compression people, man. They do the definition of the spaghetti code. There's no way.
Oh yeah.
Anyway, so let's go on. So now we're gonna now that we have a dynamic array, we're gonna have to re-implement our functions to do mallocs, which is fine. So it's basically we are constructing it, and we also need to destruct this stuff after. So we are basically picking every single type of expression that we have and just doing asking the operating system, give me some memory, and then I'm gonna give you some memory. This is the type, and so on and so forth.
It's pretty much
You
Explains.
know, you know,
inventing type constructors, right?
Yeah, this is a
you
very
know.
that feeling. He's inventing type constructors.
Yeah, don't you feel it's one liner in Haskell or something?
Go, Marinho.
So, yeah, funny thing is, the implementation at this chapter, it will probably change later when we add garbage collection, but in this chapter, uh, the language is linear, like in the sense of, linear logic. You have to use things exactly once because, like, you write the source code, right, and it's gonna build up the S expression,
Yeah.
and there's no structural sharing there. It's just, each
Oh,
expression
you're
has
talking that
exactly
this is
one.
very boilerplatey. That's what you're saying.
No, what I mean is, it's an interesting property that you will allocate each value exactly once when you parse the source code, and then as you evaluate it, each value will be used exactly once. This kind of, I'm not sure if this is intentional or if it just happened, but I think it's interesting.
Yeah, but what
Uh,
are you suggesting? So, could we use one value more than once?
Yeah.
That's the thing. We can't because there's no primitive for like duplicating a value at this point. We have no way to name values, which would implicitly give us a copy operation. We don't have an explicit copy, which means that actually each value must be used exactly once.
Ah,
So
okay. You're talking about copying. Okay, now I understand. Yeah, okay. I now I got it. Yeah, you create one thing and then you delete it. That's it. That's pretty much it. And then here it is. This is how you destroy them.
We'll
This is how you
try some.
destroy them.
Yeah.
Uh, Again, I'm passing through because this is not where it gets hard to read, in my opinion. The Q expressions for me are the hardest to read because this is basically
am
going
I
through the array and deleting each one recursively. So that's
Mhm.
fine. And when
am
you're
I the
talking about
only
numbers and symbols, that's also fine.
I
Go.
really don't like C switch expressions. I just don't.
Why not?
Uh,
Because they are not actually real expressions, and they're not even statements. Like, have you seen this thing called Duff's device?
Called what?
Duffs.
Duff's
Duffs.
device, yeah.
Like this.
Oh, device.
Yes, exactly.
The one with unrolling the loops. Guess.
Yes, that one.
I have no
Look
What
at
is
idea what it is.
look at that switch statement. Like, he starts with a loop, right? He wants to unroll it, but then it doesn't always start from the beginning,
Oh,
right? It
here.
can start from the middle. So look at that switch and the labels and the do. Like, what the heck?
Oh wait. Okay. So this is bad, right?
it?
This is really
It's very
unreadable.
nasty. This is very nasty.
But it
The problem
compiles,
is
it
that
works.
it works.
It works. What the heck this is doing? It
Yeah,
works. What the
it
fuck?
might work, but this is very nasty.
uh, yeah, but I agree that it
Come on,
sucks
guys, we
that
have compilers right now.
I agree that this sucks that this is not an expression. It's not even a statement. It's kind of weird.
Come on, this is pattern
Yeah.
matching.
No, but I mean the breaks, the fall through, like which case fall through is like why, just why?
No, I
Yeah,
have
Using
an
the
idea
range.
why. I have an idea why. I think they did
yeah.
this in the beginning because of the boilerplate, because they noticed that we don't have OR patterns. Because the falling through without the break, this is basically implementing OR patterns. So, OCaml OR patterns. There. Uh,
More better
yeah, so where is an example of an OR pattern? Here,
there.
here. It's basically this. So you're pattern matching both of them, and both of them go to the same branch.
Mm-hmm.
So this is OR patterns, and I think
Mm-hmm.
they attempted like in a draft of that with the falling of the switch case.
If
That
that's the case, then I'm very
I,
disappointed in the people who came up with this.
I believe this is way simpler than this because when we are programming in assembly, it's directly bare metal assembly. It's kind of common to use this if if and roll through something, just like the switch case. I believe
yeah, that's
they
that's
were just
that's
trying to mimic that kind of style
yeah.
programming.
But
I think we should consider
It makes
the
sense as
philosophy of
well.
C.
can
In
you
the
repeat,
first
Max?
place, C was made. Uh, I guess we should also consider the philosophy of the creators of C. In the beginning, it was a simple abstraction of assembly, like
Yeah.
Yeah,
just the bare minimum.
that makes sense. That makes sense.
I think this is where it's coming from.
Yeah, but
Yeah,
I understand. Go
Yeah,
Marin, go Marin.
you understand
I
that
can understand that, but I still don't like it.
That's fine. That's fine.
it makes sense for the time it was proposed. It,
Yeah, I think it makes sense in the context.
of course, we learned something in
Yeah, of
school.
course we learned some. Yeah, yeah, I guess
Oh,
so.
there's the note about concells.
Yeah, yeah, this
That,
is the note of our consoles.
uh,
Uh,
personally, I
oh yeah, this is because of the linked lists, right? Yeah, I remember. I remember.
yeah, because the S expression representation he's using is actually based on arrays, not
Yes,
linked
yes,
lists.
yes. He
On
wants
one
to call
hand,
himself pragmatic because it's faster, you know.
I actually don't have a problem with using a different data structure. It's just, how can I say this? I think there's a difference between the structure that you use to denote a sequence of values, which is a list, and the structure that you use to denote a function call. The function call is kind of naturally like dyadic. You have the function you're calling and a list of arguments, right? So it makes sense to represent that as a pair.
Okay.
Uh, But then the arguments list, in traditional lists, they use linked lists because you already have a console, right? So you may as well
Yeah.
just reuse it.
Yeah. Why
But
bother, right?
there's no reason why you couldn't use a different structure, like I don't know, a finger tree or a plain old mutable array or whatever.
Yeah,
So I
yeah. I
don't have
think
a
this is
problem with
just implementation details.
yeah, I don't have a problem with using a different data structure to implement lists. I think that's fine.
Yeah.
I do think it's reasonable to have a console anyway, just so you can tell apart, okay, this is meant to be a sequence and this is meant to be a functional call, because that's actually helpful when you're doing metaprogramming. Um,
Mhm.
because otherwise, how do you know for sure that this is meant to be interpreted and that's meant to be treated as plain data? Like the explicit console is kind of a marker in that sense, an annotation. You can think of it that way. Um, He
Okay.
doesn't do that obviously because he's just using a plain old array, and that's
Yeah.
the function call. Yeah, I don't think Lisps have to be married to this concept of concells. Um, they can use different structures. It's just concells are the simplest ones to implement. So that's what historically has been used because very easy.
Yeah, so this is basically how we explain linked lists in Haskell as well, pretty much. But this reminds me of bad stuff because I think you remember that we tried to use this in Racket and it didn't work that well because oh man, that was bad. And anyway, that was bad. Okay.
What would be the alternative here instead
Sorry?
of consoles? What would be the alternative instead of consoles?
You
No.
could just say that, okay, I have arrays and I use them to represent function calls. And I actually have two different types of arrays, one that's meant to be treated as plain data and the other to be interpreted as function calls. And spoiler alert, that's actually what happens in the book.
Yeah, yeah. So he's gonna create a new stuff to do the separation between what's code and what's data.
Yeah. I think that's an
But
okay approach. I still prefer the console just because like it's a bit more explicit.
Yeah.
But this works, I guess. I don't have a problem with it, and it's an alternative. It's very much an alternative.
Yeah, and you also said finger trees, right? So finger trees, arrays, and
Yeah.
concells.
Any structure that can be interpreted as as a sequence.
Yeah,
So
any structure that can interpret. Yeah.
anything that abstractly represents a list, a finite list specifically, because you don't really want to call a function with
Yeah,
an
at this
infinite number of
point we don't care
arguments.
about that. So, for instance,
Yeah.
one of the things that people love to talk shit about Haskell is how less performant it is because we have the linked lists are so slow because they are
Mhm.
boxed. In his case, he actually took the unbox approach, right? So it's faster.
Mhm.
Kinda, not really. The box versus unbox thing. I think that's more a matter of overhead and number of indirections. I think that's the main concern, actually.
Yeah,
Because with a linked list, you have an indirection per item. That's pretty bad once you have, like, I don't know, 50, 100, 200 items. At some point, the number of indirections is just gonna kill your cache utilization.
yeah, I see, I see. Well, let's go further. So we discover how to we rediscover how to read a number, and we're gonna use this function in. This is actually the only conversion that we need to do, right? This is the only conversion we need to do. We're gonna use this in the outer reader, let's say. So if you parse like a number, you're gonna use the function that we just saw. A symbol is gonna also be treated as a string, so it's fine. And then this is jumping the the useless tokens. This
Mhm.
is jumping the useless tokens. Uh, lval as expression. I think that was the one that we were. Did we already talked about this one? This one here.
Uh, yeah, the S expression is the one that's actually
L
an
as
array, right?
expression. No, no, yeah, that yes, I remember. But I'm talking about where is the function definition? I don't think we talked about that yet. Okay,
Uh,
okay.
Actually, I think we did. It's there's add, there's read. It's a little above where we are. Like there's
Where is
none.
this is the deletion? Oh, it's in here. Okay, so this is basically
Yes.
just doing the malloc and putting the type. Yeah, type constructors once again. Type constructions once again. Uh, and I think that's it. Then he starts to do the add that we saw last time, right? And he does this recursively as well. So it's just picking the children, so it's basically folding them.
Yeah. One thing about this lval add, which is
It's in here.
basically appends an item to the end of the array, right?
Yeah.
He
What a
chose the
nightmare.
least efficient way possible to implement this. Like, what the heck?
Yeah, but he chose dynamic arrays, man. He's gonna have to do the realloc all the time.
Man, he could have implemented a basic array list where like you double the size each time you need to do a reallocation, and
Yeah, but
that's
that's
Yeah.
kind of
you
like,
know,
do you agree that's like a gambiarra? Like that's a hack? You should not do that.
it's not a hack. It's a legitimate strategy. It's good for mutable languages. It's definitely bad for like functional programming because you get better you get better performance by using not performance in the sense of like raw, in the sense of big O performance, like not
No, no, I understand,
constant.
but I'm saying that this is doing what you said is a hack because, like, you don't know how much memory your program is gonna use. So you are going to the stack and basically saying, give me double, like, give me 2 gigs of memory.
No,
Uh,
but like typically an array list you start with like 8 or 16 elements as the your starting size because you expect to have a few items at least, right? And then if you need to exceed that, you multiply it by a constant, usually 2. I think Java actually uses 1.47 or something crazy like that for some reason,
no,
or
yeah, but that's the
1.5
thing.
or
That's the thing. My understanding is that if you are going for the best memory usage, you are eating the calls of malloc and realloc because, but you're trying to not use three
yeah, this is
times
actually
eight or something.
yeah, this is a space-time trade-off
Yes,
where
exactly.
you can reduce the number of allocations or reallocations, but then you have some memory overhead for stuff that you
Exactly,
asked
exactly.
for in advance. Yeah.
Exactly. And again, depending on your application, I'm completely fine with like a constant times something that you are just asking for memory. And you have some fragmentation like overhead, like you said. It's fine for some applications, but I think he's trying to
Um,
if this, I don't know where are we are going, like at the what is the final chapter, but maybe we're gonna make some crazy stuff that uses memory and stuff like that. So maybe he's trying to not use as much in here or something like that.
but then if he's worried about memory, why the heck did he make that
That's
super
fair.
wasteful
That's fair.
L
That's fair.
val struct?
That's fair. That's fair. If he cares about memory, what the heck is going on up here? Like, what the heck is this? Yeah, that makes sense. That makes sense. Ah, so good. Okay, now I think I think I went too far. Yeah, so
Yeah.
this is where I stopped. So now this is just for printing. So this is
Yeah.
not that interesting. So basically like calling these are actually mutual recursive, right? These two functions.
Yes.
So you call
I
the
know this is
print
not,
and do that.
yeah, this is not the most interesting code in the world, but can I just take a moment to appreciate the fact that Lisps traditionally have a standard way to print out and read data? Like, that's something that some modern languages nowadays don't have. And Lisp had it in like the late 50s slash early 60s. It's like, this is very
Eh,
convenient.
so because this switch case is gonna get big, man. Like this is gonna be the same. That's fair, and I appreciate that. I agree because I had to do that for our language, right? The printing. But this is gonna just get big. Like this is gonna be messy anyway. So
But it's not necessarily about how large the implementation is. It's about having a standard representation for data, like textually.
oh okay, that I can appreciate more. That I can appreciate more. This is basically saying about the mutual recursion. That's fine. And then here we are just printing grabbing parsing the input and just throwing it at the std out. That's what we are doing here. And we are removing white spaces, extra white spaces
Mhm.
as well. So yeah, now it comes the fun part. Now we're gonna evaluate this shit. Uh, So yeah. So we're gonna make some functions like take and pop and stuff like that. But let's see what happens here. So to evaluate the next expression, the first thing that he's doing is evaluating the children of the S expression.
Makes sense.
Then yeah, because in my opinion he's being more wasteful. Like it's really hard to tell what the heck he's prioritizing because sometimes he's doing dynamic arrays, so we think that he's prioritizing memory. But then we
Mm-hmm.
know that some fields in the struct is just a waste of memory. And now
Mm-hmm.
here he's wasting time because he could immediately after doing the eval, he could immediately check for the type and return immediately.
Mm-hmm.
Maybe there's a reason why he's wasting two like doing a loop twice. No idea. But this happens more than once. I remember seeing at least 3 times that wait, he's doing the same loop and he's not benefiting. He doesn't need to wait for everything to be done in here.
Yeah. See, I see
We
it.
should also consider that he's doing it for educational purposes for people who don't know C. So maybe he just does that for clarity reasons.
Yeah. Okay.
Just maybe.
Yeah. Okay. Okay. That's a possibility. No, no, no. But I thought about something clever. But I don't know if I went too far, because something that I think it would be cool is that imagine that you have a series of X expressions. Some of them are wrong, but some of them are right. If you follow through the first one and you bubble that up, you could have shown more errors. You could if you went further, right?
Mm-hmm.
And then this approach makes more sense. Even though he's not doing that because he's doing a return, so he's
Mm-hmm.
definitely not doing that. But that would be very awesome. Like this X expression is wrong, but I can go further and I can report more errors in one single go. I think I discussed that with Nathan at some point. How do they do that? How GCC does that? How do they
It just,
know how to go on?
it just keeps parsing, and they try to find some synchronization points, like the starting of functions, variable declaration,
Yeah,
stuff like this,
that sounds
and
tricky.
and kind of rewinding and starts from scratch from there, and
Yeah,
then it just keep trying,
that's
and then report
wild.
everything it finds.
That's wild, man. Anyway, so he's evaluating the children, then he checks for an errors. Then we are going for the corner cases. So if you have an empty expression, you're just gonna return v. If you have a single expression, you're just gonna take that out of the outer thing with the take. And then our operators, they are symbols, right? We have a plus and so on and so forth. So if I remember correctly, this is why he's checking for this. So he's checking if
Yes.
this is the a plus, for instance, uh, and stuff like that. So if it isn't, like if it isn't a symbol, this is an error. So we're gonna just free the memory because we don't have defer. We don't have defer. Which reminds me, Marinho, I was watching a Porth session from Zozin, and he implemented in his concatenative language defer, I believe. If I remember correctly, he purposely made that because it's so useful, so useful. And otherwise, that means that we have a symbol. That means that we have a symbol, so we're just getting the symbol, and we're just gonna do the we're just gonna evaluate now the expression now that we know the symbol and we know that everything went fine. So we're just gonna do that, and then after that we're gonna free more memory because this is C, and then we're gonna return the result.
But what if you I'm just wondering here and nothing related, but what if you want to keep a variable
We
on
don't have variables yet.
your scope? No, not here. I'm talking about this differ thing.
Oh, what if you want to keep it? Like
Yeah.
you create the memory and you purposely want to leak it.
You
Uh,
can just
I
not
don't
use the
want to leak
defer
it. I
in
want
that
to
case.
keep it for using in another scope, for
does
example.
Go provide you when you do defer in Go? Is this gonna free
But
everybody or only the ones that you pass the label,
Defer
Marin?
Defer actually has nothing to do with clearing bring memory directly. It used to say defer basically says, okay, after the defer keyword, they have a function call. Please call that function with those arguments at the end of the scope. What the function call actually is doesn't matter. It's normally used to free memory, but that's not the
Oh
only
oh,
thing
no,
you
but
can do with it.
I think I didn't express my question correctly because I was asking this. So my question was, when you do defer, don't you have the option of control what exactly you want to do, like which people you're gonna kill after the scope ends? And I think this answers my question. So you create a pointer to a file, and then at the end of the scope, you're gonna close the file.
It's like tagging something to be called at the end of the scope, right?
Yeah, yeah, and it's
Yes.
not positional, so you can put this defer anywhere.
Whatever. But you're tagging something to that will happen at the end of at the end
Yes,
of.
yes, yes, yeah, yeah. But it matters. Not being positional matters. That's one of the things.
Mm.
Uh, it's not positional if you consider defer with non-defer statements. The defers, if you have multiple defers in the same scope, they run in reverse order you were
Really? I
essentially
didn't know that.
building because they were essentially building like a scope where like okay, close file will run at the end of the current scope. If I do a defer after I do defer close file, that will actually run before the close file. Uh, it's as if the close file creates um, can I say this? Like you don't want to close the file until you're done doing the things
Yes,
that you wanna do with the file, right?
yes, yes.
You
Which
may
is
actually need
writing.
the file. Yeah, you may actually need the file on the cleanup for other stuff before before
Return.
before you go before you return. Yeah, in
Yeah.
this case. Um, so like I have an intuition for this because I think a
Wait,
lot
but you're
about
saying
programming
that you
language
can control
semantics, but
that by adding the order of the first? Is that what you're saying?
like if you have multiple defers in the same
Multiple the
scope,
first, yes.
they will run in the opposite order that they appear.
Mm-hmm.
Because there may be
Mm.
other stuff in between the defers, right?
Oh, okay, I think I see.
First, first in, last out, or something in
Mm,
reverse.
Yeah,
yeah, first in last out. Yes, that's the correct. That's
yes.
correct. Yeah, that's very interesting. Yeah, the first cool. The first cool. I don't think I used it in the bot because the bot is written in Go, but it's cool. Maybe I use it. I don't remember.
Mhm.
Okay, then we have the main eval function because this is the eval XPR. And if the type is, yeah, right now the only thing that we need to simplify is the S expression. So we just do this if and that's it. So now we're gonna take
Yeah,
a
we
look on
don't
how
have
the pop and the take works. Uh, so the pop extracts a single element from an S expression and index I and shifts the rest. So you're basically like grabbing a member out
Wait,
of that and then
transforming things.
removing the fragmentation of the memory that would happen there,
yeah, yeah,
Yeah.
which
right.
is very annoying. I
Yeah.
really don't.
You see?
Yeah, you need to do the math, which is not a very hard math in this particular case, and you need to do a halloc.
Yeah.
Yeah, and you just return the x. And the take, it's basically the same thing, but you get rid of the remaining, right?
Mhm.
So you pop it, and then you just delete everything else. That's about it.
Mhm.
This is okay. So this is basically checking if all the arguments are numbers. So you're basically checking if this
Evaluating operators.
what?
It's evaluating operators like plus,
Yeah, yeah,
minus.
it's evaluating operators. It is evaluating operators. No, no, they are not. They are already. They need to be already evaluated. This is not doing any eval. This is already
This
checking
is
for the type.
actually
But there
this
are
is
some
actually this is actually
that
applied,
are
not
there.
evolved.
What?
This is apply.
Can you-
Let me explain, Marin, 1 second. So, Edu, do you remember that when we do all of these checks,
Mhm,
at the end we call built-in OP? So
mhm.
at this point, we already know that everything is parsed
Understand.
correctly. Parsed
Yeah.
correctly.
Mhm,
And then when we go to here, we need to understand if the operands are numbers. So they are already like parsed in the sense they are,
mhm.
yeah, they are evaluated because they are numbers, right? The only thing that we evaluate is S expressions. So I think you know I understand what I mean. So we just check if their type is lval num. And if they are not, we just return an error saying that we cannot operate on a unknown number, which can be a symbol, for
Be-
instance.
yeah,
Mhm,
at this point we only have numeric operations, so
Yes,
that's why.
yes.
mhm.
Then we pick the first element. Um, this is cool because this basically means that you can do a minus with only one number, and this will actually work. It's not gonna like subtraction with what? No, it's gonna work fine.
Yeah,
Uh,
that's a Lisp thing where if you do minus with one
yeah.
argument,
I
that's
think
negation.
I don't remember. We had this conversation. I can't give you a number of the session, but during the when we were writing the language in Haskell, I think we discussed that. Are we gonna make this feature in our language or not? That you can put the minus with a S expression thing brackets and only one number. What should happen in that case? I don't remember the conclusion if we went with that or not, but I remember the conversation. I think it was Magetta that brought that up. Uh, okay, then we're just gonna do the operations now. That's basically it. And we have a very simple error checking for division by zero because why not?
Division by zero, yeah.
Yeah,
Classic.
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 And then don't forget your deletes. You need to not you don't yeah, you don't want to leak memory. And here it is, and it works, and it works.
Mhm.
Uh, very interesting that the empty line returns open close parentheses. So I guess an empty line is an as expression then. I think.
Yeah, because the way it's parsing, it's it's kind of like it's as if there was an implicit parens around the entire line.
Oh
That's
no no
why
no!
it.
It's because the empty line and the slash are actually symbols. So when we do stuff and we are not in an X expression, we just throw them to the std out as it is.
Yeah, yeah.
Uh, yeah, that's very amusing.
The
Yeah.
empty line is actually the empty S expression. It's not a symbol.
Are you sure it's an empty S expression? No, that needs to be the case because this is parenthesis. So it needs to
S.
be an empty S expression. Yeah, you're right. Which is kind of weird decision. Weird decision. I don't know when we made that decision in the code.
It's
Uh,
actually in the eval S expression, if I'm not mistaken.
this one here.
Yeah, empty expression right there.
Oh, here. Okay,
Mhm.
okay, yeah. So that's when we made that decision that empty new line is gonna be a nice expression. Cool. Now we're gonna go to the metaprogramming stuff. The metaprogramming stuff. So Q expressions is basically a fancy name for what we're gonna do with the quote, right? The quote, not the backtick, but the quote. And he explains that in other Lisps they actually use a different mechanism to do rich metaprogramming, which is macros. Um, but here he's gonna use something that he called Q expression. Q expression. And I think we already are at the point of a real cycle of development of compilers. This is pretty much it. Like you make your example and you throw the compiler and the compiler will say, I can't parse that. Then you make it parse. Then you're gonna say, I can't
Evaluate us.
I can't evaluate. No. But we are missing some steps because in here, uh, uh, the parsing is actually like quite a bit of work, and the evaluation is only this, right? The evaluation is only this because
Yes.
he has tokens, right? Every single time I think of parsers, I think of parser combinators, so I don't kind of like I don't usually think of tokens anymore. It's been a while. But here he's verifying like, can I tokenize this? Yes. Can I put this in the AST? Yes. Now we're gonna go for evaluation, and then we're gonna go to compilation. Yes. So we are kind of going to the cycle of compiler development. First things first, we're just gonna put that in our grammar, which I gotta say that it's very convenient. This thing, it's ugly as fuck, but it's so convenient because you
No,
just do this.
yeah, no, it is convenient.
It's so convenient. Okay. Then we're gonna do the thing that we already did before with the s expression. So we're gonna add to the enum. So now we can identify as a type of expression.
Actually, just go up a little bit because it's not only adding something to this string. You have to
No, you had
create
to do
some.
the cleanup here.
No. You have to create something up there
Oh,
as
you
well.
mean
Yeah,
The
transforming the
parser.
string to the parser? Yeah.
yeah.
Yeah, but these are like implementation details. What's really matters is like you need to do all of these four steps. You need to add in here, 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 and
Mm-hmm.
here. You need to do all of those every time,
Yeah.
which is kind of annoying to be honest. But it's C. There's a very interesting session that Zozin did with Rust that he noticed this pattern that every single time I want to parse something new in my flags in my program, I need to do four steps. Then he used Rust macros to make that one step.
Ooh, nice.
Yeah, that was very yeah, but the way that he did that, Rust is so weird in that regard. But we can talk about that later. Then we make the constructor of a Q expression, which is basically the same thing as an S expression. We need to be able to print those things, so we just add a new case to the switch case. And yeah, what Marinho said before. What Marinho said before about we had another print function that calls this one, and they are mutually recursive, but you don't need to care about the other one, and that's cool. That's cool. Uh,
Um,
because the other one is kind of generic in the sense of parsing lists, right? Then a deletion, we're gonna have to do the fall through because deleting S expressions is the same thing as deleting Q expressions. So you're basically gonna do the for loop anyway.
Mm-hmm.
Uh, so yeah, this is a convenient case where falling through the switch case is very useful, very convenient.
uh, by the way, can we take a moment to appreciate the fact that this convenience of reusing the S expression machinery for Q expressions is only possible because the two types are isomorphic to each other.
Yes, it's only their semantics they differ, so they are pretty much the work that you do for the one you can pretty much reuse it 99%. It's very cool. That's very cool. Like it's just a
And
matter of
also,
swapping the token.
yeah, and also they are isomorphic, but the interpreter, the runtime treats them like differently, even though
Yeah,
they have the same structure.
yeah,
I think that's something that's a little underappreciated when you're studying programming languages, but it's very useful to know.
yeah. The code as data, it's kind of seamless in this sense because at this point of the compiler, they are basically the same thing. You're just
Yes.
swapping curly braces for parentheses. Uh, then we need to add the jumping of the extra tokens that we don't care. We need to also check add the if to check the tag, which is kind of like the type of the Q expressions, and then you're gonna do the evaluation of them specifically.
Mm-hmm.
And after this, because you don't have any functions that manipulate these specifically Q expressions, it's already over. It's already done. Which basically
For
means
the
that you
rec
just you can just throw it to the std out.
for the record, I don't like the choice of curly braces. I would have preferred square brackets. That's my 2 cents
Uh,
of bike shedding.
I think that every symbol that you pick is better than the back quote, in my personal opinion. The back quote, no,
But
the
the back
quote,
quote,
the single quote. I
but the,
misspelled.
but the
I
single
really
quote
hate
actually.
the single quote. I really dislike it.
Really?
Yeah, because in some Lisps, which I'm not, of course, I'm not gonna be able to tell which ones because I'm already confused in this madness. But some Lisps you can create lists out of the quote, and in some other Lisps this is just metaprogramming.
Okay. It's not uniform.
No, it's not uniform across the entire family, right?
Mm-hmm.
And that's something that bothers me a lot because the reason that I started using backtick more than the quote, it was because of that. Because I am
What
so
does
confused. Is this the list that this creates a list? Or is this the list that I need to put the list keyword within the parentheses to make the list? I don't remember. I don't care. Uh,
Actually, there's a difference between using the single quotes and using the list keyword, quote unquote.
but
The
which
difference
list?
is
I don't
that
know.
when you
I have no idea.
I'm talking about common Lisp, scheme, closure as well. Basically, the popular ones. All three of them are basically the same in that regard, and that is if you do quote and you write a list, like a parenthesized list after the quote, that will return a completely unevaluated list. So like if there are symbols
Yes.
inside of it, if there's other parenthesized expressions, they will not be evaluated.
Yes.
But when you do open paren list and then the elements, that will evaluate the elements. So that's the difference there.
Okay, I see. I see. Yeah, but I gotta be fair. At the point that I was having this confusion with the quote, I was not very idiomatic with Lisps as I am today. I'm not a master like Marinho, but I definitely am better than before. Like if you watch Letri's first 5 sessions, it was terrible, terrible. Magetta and Commander were complaining about the parentheses to me all the time, man, all the time. Uh, anyway, so now we're gonna
I
make
don't know if
functions to go on, Marinho.
I I don't know if I would call myself a master, but I do appreciate your trust in
Nah,
my abilities.
don't even try, don't even try. Okay, now we're gonna make functions to manipulate this shit. And we're gonna make the cursed evolve, right? The ones that the racket people told us to not use. Uh,
Actually,
uh,
common Lisp people also don't like to use eval, and I think most Lisps that rely on macros don't like eval either, because like eval is a very dynamic thing, and it's
yeah,
very context sensitive,
yeah,
and it kind of makes it harder to reason about what's actually gonna happen in the code.
yeah. That makes no
Uh,
sense.
and if you
Uh,
throw macros at it, it gets even harder. So
yeah.
they don't play very well together.
I
Uh,
have here.
go,
Does
go.
does these things have to be uh, uh, like primitives on the language?
Some
Uh,
of them have because they need to know about memory representation, but some of them actually don't.
can't you make evolve aside from a built-in? I don't know if you can
Uh,
do that.
this evolve at this current point you could, but later on when we implement variables and we have to deal with environments, it would become harder until it becomes impossible,
No, wait.
basically.
Backtrack a little bit. How can you self-host an evolve? Like,
You need conditionals, you need some way to distinguish symbols from other types of values, some way to distinguish S expressions, in this case, from other types of values, and then you just do a basic conditional dispatch. The only difficulty, as I said, is as soon as you implement
no, the scoping I
variables, like,
understand. The scoping with the
yeah,
variables makes total sense to be hard. I understand that. But how, like, remove that from the equation. We don't have variables. We don't have the notion of scope yet. So you said conditional dispatch, right? Conditional dispatch.
yeah, you need basically a combination of ifs and type predicates, like list question mark, symbol question mark, that kind of stuff.
Um, oh, okay.
And
So your language needs to be able to represent itself. You said predicates, right? So you need to be able to say to have a predicate asking is this a list or not, right?
yes, Yes, you need to be able to look at your data and know what you're looking at. Like, is this a list? Is this a number? Is this a symbol?
But at this point we
Uh,
do, right? At this point we can identify as expressions, numbers, and symbols.
Not from inside the language just
Not
yet.
from inside the language, because this language is still doing like math, arithmetics. But I think now I understand what you said. So yes, it's gonna be really hard if you have scoping, makes sense. But if you don't have that, you only need to be able to recognize yourself. That makes sense.
Yeah.
That makes
And
sense.
actually, scoping is not even that much of scoping is not even that much in terms of like code for the implementation. It's just that there are nuances that you have to pay attention
Yeah, yeah,
to,
yeah, yeah,
like
yeah,
dynamic versus lexical scoping.
yeah.
That
Yeah.
the original Lisp, the original eval actually got wrong, by the way, and that's how we got dynamic scoping by default for decades. But that's another story.
I didn't know that. Okay,
Yeah.
let's go to the through the implementations of head and tail now.
Right.
Actually, just one last thing on the topic of eval.
Sure.
Actually, the fact that it's relatively straightforward to write eval in Lisp was a major point that John McCarthy used to argue that this is an elegant programming model. And it directly led to the implementation of the eval in machine language, which is how we got the Lisp interpreter, as I mentioned earlier. So
Okay. Okay. Yeah, I think it's kind of it has its beauty. The fact that it's easy to implement evolve, I can appreciate that. Okay, now let's go to the primitives of the Q expression functions.
Wait,
So,
just so that I don't get lost again on this
well,
shit. We have two structures. One is the S expressions,
yes.
which which has a function that evaluates it recursively,
No,
no
no.
matter
The S expression is not a structure. We have a single structure for all of them, right? For
how.
all symbols, numbers, and then we differentiate their type with an enum. We add error messages to them so they can have their own error messages. And in
Okay.
the case of an S expression, we have an embedded dynamic array.
No, but I was thinking in S expression in terms of Lisp, of the Lisp that the guy is doing, not in terms of the implementation.
Oh, okay. Then you can ask again. Sorry.
Okay, so we have S expressions
Yes.
that get evaluated anyhow.
Yes.
You can't control that, and you have
Yes.
these key expressions that don't get evaluated at all.
Yeah, until you ask for it.
Of course, yes, yes. This is why we are building some primitives
Yeah,
to deal.
and this is very simple. Like this is the beginning of the story because I don't know if you're gonna go through that route, but in other Lisps we have the backtick, and sometimes it's the tilde, which is like when you do the backtick, you are basically informing that this is not gonna be evaluated, but if you find, I think in Racket is the tilde. So if you find a tilde,
you,
this one, this part of it you want to evaluate. So the
Okay, you
entire
that
in other
yeah,
lists you have final control of evaluation of an expression.
yes, yes. We have
yeah,
final control.
you can basically have code templates essentially.
Yes.
Called what?
And by the way, you got it wrong. In Racket, it's actually comma. It's enclosure that it's tilde because
Amen. Amen.
enclosure
I have
and
no
actually
idea.
that's because enclosure commas are white space, so it can't be used to as the
And
unquote.
you said what is a code template, right? So imagine that you have a macro. So you want a piece of code to be copy pasted, okay?
Mm-hmm,
But you want some holes of this macro to be actually evaluated to its final form.
mm-hmm,
Some parts of it, not all of it.
mm-hmm.
Yeah,
Using
like
this mechanism that I just explained, and Marinho corrected me, you can have that. You can have that.
Mm-hmm.
yeah,
Right.
you're basically saying I have this template, but this particular piece I want to be computed right now, and I just want to inject the results right here.
Yeah. Yeah, because for instance, let's say that you're doing C macros, as he's going to explain further. You're going to be obligated to pick the arguments that you want to be evaluated, to evaluate yourself first, by yourself, and then call the macro.
Mm-hmm.
In with Lisp type of macros like closures, records, common Lisp, you don't need to care. You just the body of the macro with the backticks and other stuff. You're gonna be able to say it there in the description of the macro which points you want to go further in evaluation, which ones you're gonna want to hold. So it's very convenient. It's very
Um,
convenient.
kind of power.
Yeah, yeah. But this is only like no. I think that's overall Lisp. I was about to say something else, so forget it. Anyway,
I mean, there are the very rare Lisps that are based on factors instead of macros, and they are a whole nother different beast because they actually do call eval at runtime very frequently, and they rely on
wow,
eval instead of quotation.
wow, that's fancy. The thing that I was about to say, Marinho, but we don't have the time because it's already 1 hour, is EGE, the type of macros that you hate in Racket.
Oh, hygienic macros.
Yes, but let's not
Specifically,
go there today.
yeah.
Uh, anyway, so now we're gonna make the built-in head. Okay, so this is the built-ins to swap the built-ins OPs, right?
Mm-hmm.
Because
Yes.
now we're gonna have a special functionality. So we need to check for extra stuff. So we need to check if you have many arguments or not. We need to check if you are actually passing to the head in a Q expression. We need to pass if you need to check if you passed nothing to it. And
Mm-hmm.
if after all of that you are good, that means that you're gonna do the functionality, which is basically doing the take. So we are basically the take is different than the pop. So the take is destroying everything else, right? It's
Yeah,
just
it
picking the
takes
first one.
first, yeah, it takes the first thing and
Yes.
destroys every delete
Yes,
everything.
and delete all the elements that are not head and return. Uh, that's kind of
Hmm?
interesting. I'm a little bit confused actually because this thing for me is already destroying everybody else aside from the first.
Yeah, but you see it there in the code. He's doing pop and deleting.
Yeah, but why is it doing this if you're doing
I don't
take?
know. I have to see take again to understand this.
No, that we can take a look at take again. That's not a problem. But I think that the implementation is just like delete, um, delete everybody else and just keeps the first one. Yeah, here. So the take, yeah, it's exactly that. It's a pop and then delete the rest. It's exactly that. Delete the rest. So why are we doing the while of the destruction? Like destroying the more stuff. Why are we doing that? Why are we
Oh,
doing that?
because the value you took, it's why? Yeah, why? You take V, so the rest of A is deleted. Then if V has more than one element, so
But how can V have more than one element?
because the first element of the list that you called head on may itself be I said the list of the S expression of the Q expression may itself be a Q expression. I don't know why it's doing this in particular. For
Weird.
me, this seems like a case of doubling up on the unwrapping, which is wrong, but
Anyway, I think that's not really important for the overall functionality. Because what matters is that you're picking a Q expression and picking the first. That's what we want. And you're gonna see examples of that down the line, so it's fine. And this is the tail. The tail is pretty much the no, but it kind of makes sense now that we see the implementation of the tail because the tail picks the removes the first and returns everything else, right? So what you're doing, you are grabbing V and then you are deleting the head, right? This pop is grabbing the head of V, and you are deleting that, which means that V will only contain the tail. Makes sense. So the first argument, the first argument needs to be something. Let's see the examples. Maybe we're gonna understand better. So head of a list. Head of a list. So this is in curly braces. So this is not gonna evaluate because this is in a key expression.
Mm-hmm.
But if you pass that to eval, oh, this is the first element. Now I see. Now I see. So now we can go back here, and now
What?
we can understand it. So when you pick this, you're basically grabbing the entire list. So maybe you have head, list, list. Or maybe you did that. Maybe you did that.
Actually, no, because there's a check for that at the beginning of the function.
Oh no, yeah, this is gonna explode before that. But you're just grabbing the first. You're just grabbing the first list, for instance. So head of list, for instance, as we saw there. You want to grab the first element of that list, and the list is V.
Oh, that makes more sense then.
Did you get it, did you?
No.
Okay,
But
so
then,
no, that's
why
List,
are
fine.
you dropping?
list,
But then,
list is another primitive.
Yeah, no, no.
it is.
Yeah,
List.
for now, let's assume that it is, just for the sake of explanation. So you want to apply this head, okay? You want to apply this head.
Yeah, yeah.
This, do you agree that in because of the parentheses, this is a single thing? Everything that is highlighted is a single thing.
Oh, yes, okay.
So that thing that I just highlighted, that is the thing that we are grabbing here.
Sure.
What do we want to do with that? We want to pick the first element of the list, right? And the list is V.
Assuming there is a list there.
No, there is, because we checked everything. There is something there. There is an argument ready. That is what these ifs are checking. If we didn't explode until that point, we are good. That's what it means.
Yeah, but I found I'm not sure if I would call it a mistake or just a very weird implementation decision. But this head is not actually the same as the Haskell head that returns the first element. What it actually does is it drops every element except the first, but it's still a list, like around the elements. And I don't
That's
know
what is
why
written here.
we.
Takes a Q expression and returns a Q expression with only the first element. So
But
it picks a
why?
list and returns a list.
Wouldn't you just want to take the first element
Yeah,
to begin with?
It's not Haskell's head. It doesn't pick a list and returns an element. It picks a list and returns a list, but the second list only has the first element.
Mm-hmm.
That's what it does.
Doesn't an empty
Why?
list break the function here?
Doesn't what? Sorry, Mac?
Doesn't an empty list break the function?
Yes, an empty list should break the function.
No, because the first check it checks if. Oh wait, no, it doesn't. The first check is for the arguments list. Never mind.
Yeah, but I wanted you to understand this. So this is the argument of the head, Edu. What we are taking is actually the argument that we're gonna apply the head
I
function.
understood. I
Then
understood that.
we're gonna drop everything else. We're just gonna drop everything else. That's it.
May I see the example again,
Yes.
please?
Here's the example again. Here's the. It is a list indeed. There's the curly braces. So this is where we were confused because before Marinho and I think I was also thinking that this head is Haskell's head, which means that you're
No,
gonna.
I was expecting something else, but maybe I am mistaken because I was expecting no, there in the example. The right thing, I was expecting it to be open parentheses instead of
Curly
uh,
braces.
curly braces and curly braces instead of parentheses.
I agree, actually, but we
That's
can
big.
see in
Open
the first
parentheses
example that
have,
this list
have
thingy is actually transforming the things into a Q expression.
no problem, but I was expecting to see something like open parentheses, head, curly braces, whatever the list, and the list and just numbers like 1, 2, 3, 4, 4, and closing
Uh,
closing
yeah,
everything.
that's because it's also demonstrating eval at the same time. It's
Yeah. Like let me try to um, let me yeah let's try to go step by step. So
Mhm.
in this particular case,
Look at the next example. It doesn't even have parentheses.
That's
it
because there's a yeah, that's because there's an implicit parenthesis around the prompt, like at the beginning and the end.
yeah, there is
Oh,
an implicit. Yeah, but yeah, I agree, but that sucks. That is kind of inconvenient. But there is a parenthesis surrounding this, Edu. There
hmm.
is a parenthesis surrounding that.
Okay, so I'm calling a function and I'm giving it one thing exactly, right?
Yes,
Which
and
is
you're giving a Q expression.
right.
This
And
and the tail will remove the head and returns you the remaining, and that's exactly
and
what
the Q
happens.
expression, I have to uh, understand it or interpret it as a list of whatever it's inside.
Yeah, when
Yeah,
you
it's
see
basically
list, you basically read this as Q expression of the elements inside. That's how you read.
and the difference between a list and a straight Q expression is whether or not the elements will be evaluated when you
Mhm.
build the Q expression.
Yes. Yeah, but that was a good catch. I was not thinking about that before. Okay, now we can go back to here, but now we can understand how both of these work. So this is grabbing the first, and then this is
Dropping everything
dropping everything
except
else
the head.
except
Wait,
the
wait. This is taking the first, which is the list,
yes,
The first argument, which is a list, and
which is a
then
list.
it drops everything
and
from the
then it's
list.
processing the list later
Yes.
Yes.
while in the while loop,
No, the
for
while
example.
loop
In the
the
while
while
loop.
loop is just dropping. The while loop is
It's
just dropping.
processing the list. So
It, what do you mean by processing the list?
it's going into the list and doing something with it in it. In this case, it's
Yes,
dropping
yes,
it's
it
Oh,
is.
that's what is happening. That is what is happening. Yes,
processing the list somehow.
that is what is happening. That is what is happening.
And that's why it's called Lisp for list processing.
Yeah, but don't say that close to Commander. He's gonna be pissed. Uh,
Why?
because you remember why? Because Commander had a conversation with Common Lisp Russians experts, because apparently Russians love
Now
Common Lisp.
I understand what's happening. Okay, I got
Uh,
it. Because the checks are checking. You have to give the function exactly one thing.
yeah.
So, second, it's checking if this one thing is a Q expression.
Yes.
And the next is checking if the
Yeah. Look at this. This is
yeah
important difference.
if this is one is checking if the list I'm given a function is empty.
Yes. Yes.
And
Yes.
after all of this, I'm I'm taking the list,
Yes.
which I know already there is only this thing there as an
Yes.
argument,
Yes.
right? And then I'm processing the list,
Yes.
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 which is V in this case.
Yeah. Which
Okay.
which is again bad naming. I have no idea why like again what Max said. It's educational. Why the bad naming?
Oh yeah. V is
So
for
weird. So weird.
like okay.
Then
Yeah.
we're gonna make. He noticed that this is kind of this way of doing the error
Repetitive.
messages is kind of boilerplatey. So he
Mm-hmm.
decided to use a macro,
A
I
uh,
C
see.
a
macro.
C macro, a C macro.
Yeah,
Yeah.
yeah, I see.
So which basically checks a condition,
Mm-hmm.
delete the arguments, because again, memory management, and then you return you pass the error to the function that we already did before, of evaluating errors, and then that's how it looks. That's now the new version basically. These are the same checks as before, but yes, I do believe they are nicer to read. They are nicer to read.
Yeah, I
Uh,
really appreciate this kind of C macro, even though I know it's full of quirks
Yeah,
and things.
there is a video. I think I already sent you as well. There is a video that Zozin did with a special case within C macros, which is just wild. I can pick the video later again for you, Edu. It's wild. It's 2024 and they're still learning C things.
Yeah, sure.
uh, okay, this is the same code as before. Now, oh, this is why we got confused in the beginning. So he's actually gonna make a built-in list keyword thingy. So when you're creating a list, you're gonna just put the and you receive the A. You're just gonna put the type as a Q expression. Uh, so
What?
this is the new built-in eval apparently.
So to build a list, you just take something and put a tag on there.
Yeah,
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 that's the beauty of it because
yeah,
the arguments came in as an S expression, and the only difference between an S expression and a Q expression is the type tag.
yeah,
Ah, I see.
yeah. So
And this will need to be evaluated, right?
yeah, yeah. I think we are gonna
As
get
we
there.
are
We're
calling
getting
eval
there.
and passing these functions.
Yeah, yeah. We're gonna call these built-in functions later on. Now
Uh,
we're gonna make the eval, right? And the eval is kind of simple because you just check the conditions, right? And
one
again,
hard.
the eval should receive a Q expression and return an S expression. And because they are the same thing, aside from the what the parser is concerned, but at this level we don't care. You check it as an S expression, and
If
then
it's a Q expression, you set the type and then you call the eval that we've been
All
using all along
along.
yeah, exactly. And then you
to
just
actually
call
do
the
the
eval
work.
that we are about to see down there.
Mm-hmm.
Very convenient, very convenient. And then there's the join. The join is the one that combines, right? This is the one that combines multiple Q expressions. And for some random reason, we don't have an example, which
Yeah, but
sucks.
that was not something to come. It's something that we wrote on the other chapter.
Which one?
On the
Yeah,
we already
we
have
already
it
have
from the previous chapter.
Oh yeah, we are
yeah.
just changing what the ones that we call in there. That's right, that's right. So the a built-in join. So this is how the functionality of the join. Uh,
It's basically list concatenation.
it is, but
So
once again, this for
it
and this while.
yeah,
I'm pretty sure you
Because
can
it's
combine them.
That's
combine one.
because this is list concatenation, but it's generalized to an arbitrary number of arguments instead of only exactly two.
Yeah, this is what I thought too.
No, no, no. But my comment is that why is it doing two loops? Why?
Because it's receiving a lot of arguments in principle, many arguments, more than two,
Yes.
and he's checking if all of them are lists or are Q expressions
No,
in
I'm
this
not
case.
saying that he shouldn't do that. I'm just complaining that why two loops? If he's
Why
gonna
not?
explode the code anyway with a return, why two loops? I think you can do in one single loop.
Ah,
Anyway,
okay,
uh,
okay.
so after we check that all of them are Q expressions,
Mm-hmm.
we pop the first we pop the first, right? So you're basically removing the zero, the one at the zero position.
You're getting the first one,
Yeah, we're getting the first one.
yeah, and then you're
Uh,
recursively.
yeah. Oh, this is C. So this is every single time. Like it took me a while to read this because immutability. So I was reading this and saying this is the same crap, but it isn't because this is a
Oh no,
fucking pointer. uh,
no,
ah. So this is basically yeah, just continuing the concatenation. This is basically continuing the concatenation.
it goes recursively consuming what's on A.
Yeah, yeah. It's basically the
Unit.
add is doing the concatenation. Yeah. Ah, fuck, man. And then we delete the A, and that's pretty much it. So this is basically this concatenation. Then
Mm-hmm.
we need to upgrade our built-ins because now we have more stuff aside from just the operators.
Yeah.
So now we add list, head, tail, join, and eval. We're gonna swap. Then we can change. Yeah, then we can change the eval XPR to call built-in instead of built-in OP because before we only had arithmetic operations.
Mm-hmm.
And that's it. So yeah, that's it. So now we can create with the list function. I'm gonna call it a function. So this with the list primitive, and this is very important to understand. Do you understand what is happening here, Eju?
Now
And
I see.
yeah, so what you're doing is basically this is a Q expression, and then you
No,
are asking
everything is
eval
still
to apply this
everything
on
is
this, basically.
everything is still expression, right?
Everything is a Q expression, yeah.
You have
There.
a Q expression
And
where the
we
first
don't have
element
an X.
is
Mac, go please. Can you repeat?
If eval give us an S expression?
No, it does, but it gives us an S expression within a Q expression.
and that's actually part of the semantics of heads. If you look at the final example,
Yes.
right, it calls head,
Yes.
which will return a Q expression containing an S expression, and then we will call eval on the Q expression, which will evaluate it. Um, because it is a Q expression with only one element, when it gets evaluated, if you recall from how eval
Yeah,
was originally
I can show
defined,
you. I can show you.
if
So
there's a single element, we implicitly unwrap it and then call eval recursively on the
where
inner
in the
element.
heck it is? Uh,
I think it's the previous chapter actually.
Previous chapter. I also remember a comment. Yeah, single expression. Is it something like this that you wanted, Marinho?
Yeah, if there's a single expression, you take the first element, and because the first element is itself an S expression, it gets recursively evaluated before we reach this case. And because the expression is actually plus 1, 2, it's going to perform the addition. So the return is a bare 3 outside of a list.
Yeah. Yeah, but this is very inconvenient. This is very not educational. This difference, like why this has curly braces and why this doesn't.
It's a bit confusing.
Yeah, it is
It's not
confusing.
It is.
it is
Like
confusing.
I don't see the plus, like the motivation why he would do that. Why he would make such a
Yeah,
difference.
yeah, the semantics he chose for the head operator. Why wouldn't you just unwrap the value? Like, what's the point?
Yeah, very weird. So so everybody here is on the same page. So let me repeat it. Marinho, you can correct me if I say something wrong. The reason why this guy is surrounded by curly braces and this guy is not surrounded by curly braces is because of the semantics of the head function. What
Mm-hmm.
does that mean? That means that because the head picks a Q expression and returns a new Q expression with only
Sure.
the head of the former Q expression, the result of applying eval on here is basically going to say um, pick the number one and put in within curly braces, and that's it. And the eval will make that happen. Is that
Mm-hmm.
right, Marin?
It is right, yes.
Okay.
Yeah.
And then the second case, what's going to happen is the following. This,
Add the fuel expression. It will take the first one,
yes, it will take the first one, which in this case is going to be
but uh, uh, an S expression wrapped in a Q expression,
yes.
Yes.
That's my understanding as well.
right? And then we call an eval on this thing.
Yes, yes. And the eval
But
go.
eval will see eval will see the S expression inside,
Yes,
and the S expression has to be evaluated because this is
yes,
what it does.
yes. The eval does the conversion when it does this, when it does this.
Eval does not wrap the thing back into yeah, it returns an S expression.
Yeah, so this casting is actually transforming the representation of the final thing. So that's why it's unwrapping. That's my understanding.
Mm-hmm.
Marinho
No,
can correct me.
actually, that's not quite right. What's happening is, okay, so the head will return an S expression wrapped in a Q expression.
Yes,
The eval will effectively convert the Q expression into an S expression. So now you
yes,
have an S expression inside of another.
yes,
The important thing is that you call eval, it will see, oh, this is an S expression, so let's recursively evaluate everything inside of it. And because the first element is an S expression with plus 1, 2, it will become a 3, right?
yes.
So then we now have an S expression with only the number 3 inside of it. And if you go back to chapter 9, when you have an S expression with only one thing, the results of the evaluation is that one thing, basically.
Yeah, but now my
It's
question is, if we do the same procedure, so the head will pick number one, so it's going to be one wrapped in a Q expression, wouldn't the eval transform the Q expression in an S expression again?
yes,
But then why we have curly braces here?
because
Your evaluation head.
the argument being passed to eval in this case is the Q expression containing head and the S expression list 1, 2, 3, 4.
Mhm.
That's what's getting evaluated.
I don't get it. Can you repeat?
Like the difference between this line and the last one is that
Yes.
in this case the head is inside curly braces,
Oh, I
and in
didn't
the last
see that. This is parentheses. Okay, now it makes
one,
sense.
yes.
Okay, I completely lost that part. Okay, it's funky parentheses. That makes sense.
Mhm.
Okay, now I see. Now I see.
And that's another reason why I would have preferred square braces instead of curly braces, because they are easier to distinguish from parentheses
Oh,
visually.
definitely.
Okay, that was
Definitely.
tough. The two chapters that took more time discussing than any other set of chapters. So I'm gonna finish the recording now.